So let us see the question that is written on the board. The value of limit n tends to infinity, greatest integer function of x plus greatest integer function of 2a square x plus greatest integer function of 3a square x till greatest integer function of n square x upon n cube is x by 3. Okay. So one thing to notice here is that in the numerator all the values are inside greatest integer function, but the answer we need to prove is and the answer we need to prove does not contain greatest integer function. Okay. The next thing that we need to look here is one thing that may strike you is that the limit is on n, not on x. Okay. So if I take it something like this, if I write like this, limit n tends to infinity, greatest integer function of x. If I take greatest integer function of x common in each and every expression, then it will be 1 plus 2a square can be taken outside of greatest integer function because it is integer. Okay. So this is nothing but n into n plus 1 into 2n plus 1 by 6 upon n cube. I hope you are aware of this particular thing. Okay. So if it comes like this, then we may apply the limit and we may get the value as greatest integer function of x upon 3. Okay. Now see, the answer was not containing greatest integer function of x. Okay. That means somewhere this question wants us to think that when the value of n goes higher and higher, then the value of greatest integer function x, there is somewhere that greatest integer function we have to get rid of the greatest integer function. Okay. So yeah, in objective type many students might be tempted to just take this particular option from here, but I will proceed in some another way because I have to teach you. Okay. So think of this like this. Let us start from very scratch. Let us start from very scratch and write what does greatest integer function of x mean. Greatest integer function of x, the definition is greatest integer less than or equal to. That means I can write it less than or equal to x and greater than x minus 1. Okay. This is the definition of greatest integer function, that greatest integer less than or equal to. Okay. So it is less than it or it is equal to it and greater than it. Now if I take another term 2 square x, what I can write? I can write it 2 square and x, and here I can write 2 square x minus 1. If I write 3 square x, then similarly we can write like this 3 square x and 3 square x minus 1. Okay. So if I proceed like this, till n, then it will be n square x minus 1 less than equal to n square x and less than equal to n square x. Now what we need to do? We need to simply add all of these terms. What I am trying to apply? Sandwich theorem. Okay. I hope you might be aware of what the sandwich theorem states. What sandwich theorem says, that if there is a function f of x, g of x, h of x. Okay. If we are having a function g of x and we want to evaluate it, for example say limit x tends to k gx, and we are unable to evaluate it, due to some constants. Then if you are able to find a function like this, that is g of x is greater than f of x and smaller than h of x. It may be smaller than or equal to also even, or greater than or equal to, no matter. Now if I apply the value of limit x tends to k here, limit x tends to k here, okay, and if these two terms agree on a common value, for example this is L and this is this particular thing and this is L, then I can say that this function also goes to, its limit is also L. So this is known as sandwich theorem, okay, this is known as sandwich theorem. Why? Because a function is being sandwiched between two functions. So this was not a rigorous explanation, but I hope it would have made a sense or given a bleak idea of this particular theorem. Now adding all the terms on left hand side, what we will get? We will get 1 plus 2 plus 3 dot 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 n square, okay, x minus 1 being added n times, and then in between it will be this function that we are interested in finding, 1 square x plus 2 square x plus 3 square x dot 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 n square x, and on the extreme right it will be what will be, it will be 1 plus 2 square plus 3 square plus till n square into x, right. This term we get. Now I have to divide it by n cube. Why I need to divide it by n cube? Because in the question it was in the denominator n cube. So I will divide both sides by n cube, and I will take the limit as infinity, limit n tends to infinity. Here also I will divide by n cube and take n tends to infinity. Here also the same thing, divide by n cube. Now see, this particular side n square is there, limit n tends to infinity. This will be here it was 2 square 3 square like this, okay. See, here it was 2 square 3 square, I made a mistake, 2 square 3 square like this. So this summation will be n into n plus 1 into 2n plus 1 x by 6 minus n upon n cube, okay. I am taking the left hand side, and I will not write again and again this particular thing, it is just so if I apply n tends to infinity, what I will get? Here also it was n cube. See, n and n cube, one n may get cancelled and it will be n, I can directly write it like this, 1 plus 1 upon n, dividing this by 1n and dividing this by another n, 2 plus 1 upon n, okay, and 6, right. This n square went here, and then n x and then 1 by n square. So this particular term will go to 0, this particular term will go to 0, this will go to 0. So the answer will be here from here 2 by 6 x, okay. So this will be equal to x by 3, okay. The term on the left hand side came as x by 3, and here it was equality and then this particular term, and then we will find the value of this. So what it will yield? It will give us limit n tends to infinity n into n plus 1 2n plus 1 by 6 n cube into x, okay. The same thing that we simplified there, and this is nothing but x by 3. So see, here also x by 3, here also x by 3, and a function is being sandwiched between them. So we can say that the value of this limit, the value of, by sandwich theorem, the value of limit is equal to x by 3. So, I hope this question was clear to all of you all, and in case if you are having any difficulties, please do feel free to write in the comment section, and if you have learned anything from this video, please do like and try to share it. Thank you.